All right. Mm-hmm. Mm-hmm. Okay. No problem. Yeah, I think we always like start with from the very beginning, but this is not from the very beginning. Okay. The start of everything. Like this is a new topic. Yeah. Okay. Going to the mountains. You've never been to the mountains? This problem first. Okay, so we've already converted the pressure to Pascal, from kilopascal to Pascal, and we need to convert the density of water from grams, cubic centimeters to kilograms, um, kilograms per cubic meter. Okay, so that is 1.0 grams, then 1 cubic meter. So we convert this to kilogram. This is just 1,000. No, 1 kilogram is 1,000 grams, right? 1,000 grams. And then 1 cubic um, centimeters, we convert this. You know dimensional analysis? So 10 centimeters is 1 meter is equal to, no, 100 centimeters. Yes. So we need to cube this. And of course, you need your calculator. So this is 1 times 10 to the negative 3 kilograms. And this one is cube, 100 cube. It's 1 million. No, 1 gram divided by 1 divided by 1,000. Okay. So the density of water is just 1. You tell me if I'm too fast. Because sometimes I just, talk and talk, and then I forget that I have a student. Yeah, sometimes I talk to myself. Like, I forget that I'm talking to my student. Yeah. Yeah, this is new. Like, this is a new problem. The same topic, but new problem. So, I'm excited to solve them. Why? Okay, why we're converting everything? Why? Because we are asked for the height of the barometer. Do you know what a barometer is? Yes. So it is used to measure the pressure. Yes. Barometer. That one is an instrument used to measure atmospheric pressure. That is the pressure exerted by the air in the Earth's atmosphere. So to solve for, we are asked for the height of the column. It says, what would be the height of the column in a barometer? So to solve that, pressure, we use this formula. Pressure equals density times acceleration due to gravity times the height. And then we derive that. We can solve the height of the barometer, which is pressure divided by the density times acceleration due to gravity. The acceleration due to gravity is, I will just give, it's already given, 9.81 meter per second squared. the unit of the acceleration due to gravity that we're going to use is meter per second squared. That's why we're converting the cubic centimeters here to cubic meters. All right. I hope you're not confused. We will go back to from the very beginning. All right. Okay, no problem. Okay, so let's go back to the problem. Okay, I'm gonna read the problem again. What would be... no, the barometer, that one is, was this? The instrument used to measure the atmospheric pressure. But in the problem, we're given the pressure. Right? See, what would be the height of the column in a barometer if the external pressure was 101 kilopascal and water with density 1 gram per cubic centimeters was used in place of mercury? So to solve this problem or any problems, you have to take note of the given values. So we're given here the pressure 101 kilopascal, and we need to convert that to Pascal. All right? It depends. It depends if... All right, your question is, do we have to convert kilopascal to Pascal all the time? Yeah. Yes, we have to. Maybe not all the time, but we have the kilo here prefix. You need to memorize that, all of the prefixes. So we can just write that in Pascal. And Pascal is equal to Newton per meter. Newton per Pascal. 1 Pascal is 1 Newton per meter squared. We need to convert the kilopascal to Pascal, so it will be easier to compute. All right, okay. How I wish I had, a bigger screen. Okay. Okay. All right, okay. No problem. So you should know the prefixes in chemistry. Or, okay, just the prefixes. Let me write here. No problem. You're not slow. It's just you're new to this one. No, I don't think so. You have prefixes. We have, okay, from the deci, centi. This one is kilo. That means it's times 3. Maybe I should 1 mono di, and then tri, and then for measurements you have kilo, milli, what else? Yeah. Okay, prefixes. Can you see it now? Okay, so we start with from the, okay, exa, peta, tera, but these are rarely used in calculations. Then giga, of course, gigabytes. Yeah. So this is equivalent to, these are the symbols, or these are the words of prefix, the name of the prefix, name, symbol, then value. So this is 10 to the 18, 10 to the 15, 10 to the 12. Giga is 10 to the 9. Say for example, 9. Say for example, you're given 2 gigabytes of whatever storage. So that means this is 2 times 10 to the 9 bytes. See? Because giga means 10 to the 9. And you're given 2 gigabytes. So this means bytes, but in giga. So 2 times 10 to the 9 bytes. Got that? Okay. So the next one is mega. Mega, symbol M. Mega is 10 to the 6. Then we have kilo, symbol K, that is 10 cubed. Then hecto, H, 10 squared. Then deca, deca K or C, deca DA, that is 10 to the 1 or times 10. Then we have deci, deci, symbol D. That's why I don't use the D for density. I always use the rho because D can mean deci or diameter. Alright, so deci, that is 10 to the negative 1. Then centi, C, 10 to the negative 2. Then you must remember this, all of this. Milli, like 10 to the negative 3. Say for example, you're given 2 millimeters. Okay, the unit here is meter. You just add milli. So that means this is 2 times 10 to the negative 3 meter. Got that? Okay. Okay, let me write down the rest first. So we have micro. This is 10 to the negative 6. Then nano, which will be used by later. This is 10 to the negative 9. Then pico, P, is 10 to the negative 12. Then femto, this is very useful. All of this prefixes 10 to the negative 15. And then atto, symbol 10 to the negative 18. So pico is just equal to micro. So pico can also be called as micro. But just say it. Yeah, can also be called micro, double micro. So micro, because that is 10, it is equal to 10 to the negative 12. Okay. Value or multiplier, we call this is the value of these prefixes or the multiplier. Alright, so you tell me now when you're ready to solve the problems. Let's solve the problems? Okay. Okay, you can go to the next page so I don't have to delete this. Alright, okay, let's go back to the problem. What would be the height of the column? Okay, we are asked for the height of the column in a barometer. In a barometer. If the external pressure, okay, given the pressure external, which is 101 kilopascal, and water was used in place of mercury, and we're given the density of water, which is 1.0 gram per cubic 1 cubic centimeter. Okay, now to solve for the column, barometer column, we use this formula. Pressure equals density times acceleration due to gravity times height. And now to solve for the height, we just derive this. We divide both sides by density and acceleration due to gravity. This cancels out. Therefore, the height is just equal to pressure divided by the density times acceleration due to gravity. Now let's go back to the pressure. We need to convert this to Pascal. So converting this to Pascal, we just multiply by 1,000, right? Yeah, because, okay, let me write here. 1 kilopascal is equal to 1,000 pascals. So we convert 101 kilopascal, we just multiply by 1,000 per 1 kilopascal, and this would give us 101,000 pascals. All right? No questions in that? Why we need to convert to Pascal? We need to get rid of the prefix kilo. And 1 Pascal is equal to 1 Newton per meter squared. So which we're going to use later for the height. Because in the choices here, have you noticed? A, B, C, D, E, the choices is in meters. So we need to convert everything in meters. Our answer should be in meters. Okay? So we won't be in trouble. And then for the density, we have 1 gram per cubic centimeters. It's cubic centimeters. We need to convert that to cubic meters. And we need to convert grams to kilograms. This is what we're going to do. So density of water. Let me use another color. You would really see that. Okay, density of water. So this is 1 gram times 1 kilogram per 1,000 grams to get rid of the gram. And then 1 cubic centimeters, we convert that to meters. So 1 meter is equal to 100 centimeters. Okay? You need to familiarize yourself with the basic conversions, unit conversions. So 1 meter is, yeah, you have to memorize all of those. Unit conversions, especially those common units. So 1 meter is equal to 100 centimeters, and we need to cube this. So we convert that to cubic meters. And then, okay, use another color. We cancel out the grams here. We cancel out the cubic centimeters. So we're left with 1 over 1,000 kilogram divided by 1 over 100 cubic meters. You got that? Okay, so now we use the calculator. So this is 1 over 1,000. So this is 1 times 10 to the negative 3 kilogram over, what is 100 cube? 1 divided by 100 cube. So this is 1 times 10 to the negative 6 cubic meters. And then we simplify. We simplify that. 1 times, yes. So that is 1 times 10 to the negative 3. Make sure you know how to use your calculator. If you don't know how to use it, then your answer will be wrong. You can also use solve this manually. Like if you have the same basis using the law of exponents, if you still remember in algebra, the same basis, if you divide expressions with the same basis or terms with the same basis, you just subtract their exponents. So that is negative 3 minus negative 6. Okay. 1 times 10 to the negative 6. So this is 1,000 kilogram per cubic meter. Okay, so we've already converted everything. All right, and then okay, I forgot to write here acceleration due to gravity G. is 9.81 meter per second squared. So that is the value of the acceleration due to gravity. And the symbol is G. All right? What's that? The density? Okay, the density is one. Okay, you don't need to. I will just memorize them. Okay, so density of water, we already converted. So that is 1,000 kilogram per cubic meters. And then the pressure is 101,000 pascals. And acceleration due to gravity is 9.81 meter per second squared. And this is the formula. Pressure equals density times acceleration due to gravity times height. How to solve for height? That is pressure over density times acceleration due to gravity. Okay, the reason why we converted everything, so it will be easier to solve, and then we can just plug in everything, right? We can plug in here the pressure directly. See, 101,000 pascal divided by, okay, we change pascal to Newton per meter squared, so you can really see it. It's just the same anyway, because 1 pascal is equal to 1 Newton per meter squared. Okay, then divided density, 1,000 kilograms per cubic meter. Then acceleration to gravity, 9.81 meter per second squared. All right, let's check what we can cancel here. So we can cancel the meter cube, meter squared, and meter. All right. Okay, you should know that 1 Newton is equal to kilogram meter times meter per second squared. Okay, so you can cancel out. Yes. So can I change the Newton here to kilogram per meter squared? So if we're going to change here kilogram times meter per second squared, so that means we can cancel a kilogram from here, right? And then second squared from here. Then we are left with only meters. Make sure that your answer will be in meters. Okay? So now you know what kilopascal is, what pascal is equivalent to, and what Newton is equivalent to. And you must know the unit conversions. You should know how to convert all of the units. Yeah, you should have known this first. Dimensional analysis. Similar to unit conversions. And you should familiarize yourself with all the units and their equivalent units. You tell me when you're ready for the calculation. Okay, so we have 101,000 divided by 1,000 divided by 9.81. Okay, this is what I get. 10.2956, so this is 10.30 meters. So this is the height of the column in a barometer. So the answer here is letter D. Now you know how to solve that. Yeah, okay. Yeah. So these problems you sent me, are these your homework or for review only? Can we go to the next problem? Alright. Okay, can you move to the next page on the lifeboat? Gallium melts just above room temperature. Gallium is an element from the periodic table, Ga. Okay, you should also familiarize yourself with the elements in the periodic table. Melts just above room temperature and is liquid over a very wide temperature range. Okay, gallium is liquid over all right. Yeah, only that one, even only the beginning or the start of it. Actually, you can upload a photo. You take a screenshot of it and then you can upload a photo. Okay, so let's solve this problem. So gallium melts just above the room temperature, liquid over a very wide temperature range from between 30 to 2204 degrees Celsius, which means it would be suitable fluid for a high temperature barometer given its density. So density of gallium is 6.0 grams per cubic centimeters or centimeters cube. What would be the height of the column if gallium is used as the barometer fluid? Oh, the same formula. So height is, what's that? Pressure is equal to density times acceleration due to gravity times height. So therefore, height is just equal to pressure from the previous problem. Okay, are we given here the pressure, which is 9.5 times 10 to the 4th Pascal, and given the density, we convert first the density. Yeah, density is, okay, we convert this to kilogram per cubic meters. So this is, what's this, times 1 kilogram over 1000 grams. Then this one is times 1 meter over 100 centimeters, and it should be cube. So this is just equal to, using your calculator, that is 6 divided by 1000. 6 times 10, so this is 6 times 10 to the negative 3 kilograms over 1 divided by 100 cube. That is 1 times 10 to the negative 6 meter cube or cubic meters. Then we simplify. 6 times 10 to the negative 3. Okay. Divided by 10. Okay, so this is 6,000 kilogram per cubic meter. Then we can solve for, what's this? We can solve for the height. And also the acceleration due to gravity is 9.81 meter per second squared. So now we can solve for the height. We just plug in everything. So height is pressure, which is 9.5 times 10 to the 4th Pascal, over density, which is 6,000 kilograms per cubic meters, times 9.81 meter per second squared. So we'll be left with, okay, let me change the color. So we'll be left with meters here. So this cancels out, kilogram. Okay, so our answer should be in meters. Make sure you know how to, what's this? Use your calculator. 9.5. You don't need the best calculator, just a scientific calculator. Show me everything you have there. You already have it. Yeah. You don't need like the complex calculator. Just a scientific calculator. This one is a scientific calculator. Calculator if you want to plot graphs, if you do surveying, like what my papa had, like you input all the coordinates and like that. But in solving problems like this, you can just use the scientific calculator. All right, so we're here. 9.5 times 10 to the 4th Pascal divided by 6,000 divided by 9.81. So I got 1.61 meters. So this is the height of, what's that? The height of the column if gallium is used as the barometer. So that is the answer.